My name is Maria Silveira. I'm a soil scientist at the Range Cattle Research and Education Center. My involvement with biosolids has started during my PhD project many, many years ago. I did my PhD on biosolids, heavy metal in biosolids. And hopefully after this presentation, you understand that heavy metals are no longer a problem in the United States. Also, as you can tell by my accent, I'm not from United States. Where I come from, heavy metal still continues to be a big issue. But we have to keep in mind that different countries treat biosolids differently. So in the US, biosolids contain virtually no heavy metals, but that's not the point of my presentation. Unlike some of the previous webinars that you've probably seen, the format will be slightly different. I'm not going to be sharing any research data with you. I won't bore you with graphics and tables. Rather, what I intend to do is go over some of the proposed changes in biosolids regulations. Maybe a couple months from now, all I told you today might not turn out to be what the state agency implements, but I just want to warn you what the direction might be, and maybe seek your inputs if you have opportunity to share with your legislator or have any inputs on how these proposed changes are going to be incorporated. I think that would be a good idea. So main intent of this presentation is for educational purposes, maybe also clarify some misconceptions related to biosolids. Biosolids has always been a controversial topic, but more so recently because some apparent relationship with water quality, but we're going to discuss that as well. So first thing, if you Google, if you never heard the word biosolids, okay, not moving. Okay, yeah. I want to define the terminology, because if you never heard the word biosolids, you might be thinking, well, is that sewage sludge? Is that human waste? What exactly are the difference? And I want to emphasize that the terminology is very important. If you Google biosolids, and I use these words, biosolids, water quality in Florida, you're going to be overwhelmed with the amount of popular press articles. And I purposely didn't include the source of these articles because I don't think they're necessarily helping with the discussion and the educational purpose. So you're going to see that these popular press articles might refer to biosolids as human waste, sewage sludge, and the list of terms goes on. And I want to take a step back and define what are biosolids. Is it really raw human waste? Because that gives a bad connotation when you talk about raw human waste. Is that what really farmers are using in the field? Are we spreading poop, untreated poop? No, the answer is no. So biosolids, it's a term that was created probably in the early 2000s to differentiate those materials that undergo a number of treatment processes in order to be land applied. So by definition, these can be solid or semi-solid or sometimes liquid material that are produced during the domestic wastewater treatment process. So the final product that's being treated and meets regulatory criteria, those are the materials that we're referring as biosolids, and can be land applied. So the raw sludge that goes to a landfill, for instance, that's not biosolids. That's sewage sludge, and that doesn't go through all this treatment to reduce pathogens and some of the pollutants. So that's not the same type of material that farmers are using in their land. The ones that are using are, and again, we want to keep the terminology correct. We're talking about biosolids. Everything else, you can call whatever you want to, but we're talking about this treated material. They have a number of agronomic benefits. It contains nutrients, it contains organic matter. For our Florida sand soils, organic matter is very important. It helps retain moisture, helps retain nutrients. So there's a lot of positive benefits associated with biosolids. Likewise, as anything in this world, if we don't use properly, it can become a problem. Water in excess can become a problem. So it's also important to keep in mind that there's certain things that we need to consider when we're using biosolids as a source of nutrients for crops. So what are the disposal options? Depending on the size of the municipality, if it's a small municipality, that biosolids can be transferred to another facility. It can go to landfill, which is not an environmental friendly option, but a lot of our biosolids, 1/3 of our biosolids in Florida go to landfill. By the way, let me just step back. Biosolids is always in plural. It's always biosolids, even when we're referring to one single material. Depending on the level of treatment, it can be distributed and marketed as fertilizer. So it's not uncommon if you go to a hardware store, you might find a bag of biosolids. And especially in the urban environment, people might be spreading biosolids without even knowing that they are using their front lawn. It can be used as a filler for fertilizer. And the other less common ways to dispose biosolids, especially in Florida, is incineration and bioenergy. Not really using, those two options are not really used in large scale. But most of this presentation will be focused on land application. So how can we beneficially reuse this material that contains nutrients and can also provide other benefits? So, and I forgot to mention some of the slides that I'm going to be presenting. I want to credit the source. So these slides were adapted for some of the Biosolids Technical Advisory Committee presentation. So this particular one I adapted from Maurice Parker. He's our biosolids coordinator with DEP in Tallahassee. So I want to credit him for this slide. I made some slightly changes in his original slide, but the credit goes to Maurice. So in Florida, we produce about 340,000 dry tons of biosolids per year. About 2/3 of that 340 is beneficially reused. So it's almost even split. 1/3 goes to land application, 1/3 goes to distributed and marketed as fertilizer, and about 1/3 goes to landfill. So I did a very quick calculation, and if we consider the population of Florida, 21 million people, about 70% of the population, let me rephrase, 30% of the population is under septic system. So that means that the remaining 70 is generating this biosolids. And if we divide that by this 340, the 2/3 that are beneficially reused, we'll come up, if my calculations are correct, with about 46 pounds of biosolids per person per year in Florida. I thought that number is fairly low. So the municipalities are very effective at treating the domestic wastewater. In one of the slides, I'm also going to present, on average, each person in Florida produces about 100 gallons of domestic wastewater per day. Imagine that, multiply that by 21 million people. You can imagine the large volume of wastewater that these facilities are treating. So it's pretty impressive how this is treated. Some other countries, they're simply disposed in the rivers, and of course, that can be the worst case scenario. So I mentioned 1/3 is land apply, and that's basically the bulk of my presentation will be on this 1/3. In terms of imports, we used to import more biosolids from other states. In the past decade or so, we significantly reduced the amount of biosolids that are imported from other states. So we produce our own biosolids. We don't need additional ones. Recently, we only have about 10,000 to 20,000 dry tons that are marketed, distributed as fertilizer in the state. I also want to put things into perspective. So this is another, I want to acknowledge the original author of this slide, Dr. Jordan O'Connor, who's also TAC committee member, and I'm going to explain what the TAC was and what the intent was of that committee. But he used this data that was produced by Dr. Reddy. He's a professor in the Soil and Water Science Department in Gainesville. Unfortunately, you're going to see this is a little bit outdated. This is data from 20 years ago. I'm trying to come up with more recent data. Unfortunately, this big chunk of the pie, I can't find that number, the most recent numbers for fertilizer. So what I'm showing this pie chart here is how much phosphorus we import on an annual basis in Florida. So this is 20-year-old data that was generated 20 years ago. So keep in mind that some of these values might be slightly different. back in 20 years ago, we had about 61,000 metric tons of phosphorus imported in Florida per year. And if you look at the distribution, how much comes from the different sources, the vast majority was fertilizer. So even though the absolute values might be slightly different, the proportion is pretty much remains the same. Vast majority of phosphorus import in Florida comes with fertilizer. In this case, biosolids represent about 3,000 metric tons. 20 years ago, that's 5% of this number here. So relatively small proportion compared to inorganic fertilizer. If we think, I told you we produce 340, 2/3 are beneficially reused. So if I multiply 340 by 66%, I come up with this 224. Average phosphorus concentration in biosolids in Florida is about 2%. So I came up with this most recent estimate of about 4,500 metric tons of P added every year in Florida via biosolids. And that's compared to about 3,000 that I showed in that previous picture. So it's slightly increased. Of course, we have a greater population. 20 years, we increased the population quite a bit. But we also increased the consumption of inorganic fertilizer. So if we look at the typical P biosolids application rate, and this is data from DEP, the average biosolids application rate in the state is about 3 tons per acre, 3 tons of dry material per acre, fairly low. And I mentioned that materials typically contain about 2% phosphorus. We come up with an average application rate of about 0.06 tons, which is about 60 kilos, roughly 100 pounds of phosphorus per acre per year. So, and keep in mind that the sites that receive biosolids, especially in large operations, they don't repeat the application every year. Especially the large scale operations, they don't come to the same site in 5 or 10 years. So they don't reapply phosphorus in 5 to 10 years. I also want to putting things into perspective where phosphorus is applied. Again, I'm referring back to the data from Dr. Reddy 20 years ago, and he showed that also the distribution of these different phosphorus sources in the state is not even. So there's parts of the state that receives most of the phosphorus imports, and basically it's the San John Water Management River water basin and the South Florida water management. That's where most of the phosphorus imports occur in Florida. We used to have stats for each county in Florida, how much fertilizer was marketed. That information is no longer available. So it's very hard to come up with these numbers, more recent estimates of phosphorus fertilizer P inputs in Florida. But back to biosolids. In order for me to explain to you what are the proposed changes, I need to explain what are the current regulations. So I'm gonna very briefly, I only have about 15 minutes, so I'm not gonna get into the details, but hoping I'm gonna highlight at least the most important points relative to current biosolids regulations in Florida. So there are 3 types of biosolids in Florida according to the regulations. There's Class B, which are primarily used for land application. So the Class B is the material that meets the minimum required to be land applied. So it's not, again, not raw human waste. It goes through different types of treatments, so it meets that criteria to be land applied. Because it contains pathogens, there's some site restrictions associated with Class B biosolids. Some of you that are familiar with the center, if you are driving towards the 30 acres, you saw a sign, biosolids application site. That's one of the requirements. There's a grazing restriction requirement if you're using Class B biosolids. You cannot graze the pasture for 30 days. There's also Class A and AA in Florida. Those are materials that are processed further. So there's virtually no pathogens, and they are the highest quality in terms of handling. That doesn't necessarily translate into better agronomic or better agronomic response or a less environmental response. In fact, we have Class AA materials that have high soluble P that can be more susceptible to losses than a Class B material. So the Class A, AA, and B only refers to the pathogen levels and some of the metals that are present. in the material. But as I said, metal is no longer a problem in Florida. So even the Class B material contains negligible amounts of metals. And the regulations in Florida are based on how they are used, the type of crop they are using, they are being used, and the class of material. So we are in Florida, we are probably one of the most restrictive states in terms of biosolids regulations. We're subject to federal regulations. We also have state regulations, and about 1/3 of the counties in Florida also have local ordinances. So it's a heavily regulated material. It's not different if you compare, for instance, animal manure. There's essentially no regulation on animal manure, but biosolids are heavily regulated. So at the federal level, there's this standard we commonly refer as Part 503 that explains some of the requirements for pollutant limits, how much maximum load that you can apply in a particular site, the management practice associated with managing that biosolid. But also, we also have state regulations that in many cases are more restrictive than the federal regulations. The state regulations were initially based on the federal, but it contains some additional provisions. For instance, Part 503 doesn't address phosphorus concerns. Phosphorus is a big environmental problem in Florida, so the state regulations address potential for phosphorus movement from sites that are receiving biosolids application. And in one of the following slides, I'm going to also explain these state regulations went through different revisions. The most recent one occurred in 2010, and I think we're going to see perhaps this year another change in the state regulations. But the major change in 2010 was the inclusion of this nutrient management plan, what I'm calling here in NMP, the nutrient management plan. And I'll explain to you what exactly that comprises of. And as I said, many counties have their local ordinances, mainly related to odor issues and things that can not necessarily affect human health, but it's more like a nuisance issue related to biosolids. I don't know, in my screen, these numbers don't look really nice, but these are the metals that are regulated at the federal level. So regardless of the material, and this is the column on your left or your right-hand side is maximum concentration, the ceiling concentration for the biosolids. So this is when you analyze the material, if it contains more than 75 parts per million of arsenic, it cannot be land applied. I mentioned the class AA is consisted of materials that undergo additional treatment process. Usually the metals are much less, the concentrations are much lower than class B. So how did EPA came up with this number? It was a very detailed risk assessment study that considered different pathways for exposure. And that's how they came up with these numbers. If you are interested, I can provide you with the link. So that some of the pathways, the most drastic pathway for exposure to me was a child eating biosolids. The likelihood of that happening hopefully is fairly slim, but EPA considered the route when they developed this risk assessment for the ceiling concentrations. So this is the ceiling concentrations refer to maximum concentrations present in the material, but also depending on the load, how much you're applying, there's also some restrictions on the cumulative pollutant loading. I'm not presenting this table, but I just want to point out that it's not only concentration, but also depending on how much you apply, there's a maximum limit of the pollutant load. So if you are haulers or marketing, if you are a hauler transporting biosolids, or if you're marketing, or if you are receiving biosolids, these are the type of analysis that by law you are required to provide or have in order to use land apply this material. I'm not going to go over basically repeating what I just said, the metals and of course the nutrients. Calcium carbonate equivalents, that's for materials that are, I mentioned there are different treatments to achieve that class B or class AA material. One of the cheapest, most common treatment processes adding lime or alkaline materials to reduce pathogen levels. So if you have materials that are treated with this type of material, it's important to analyze for calcium carbonate equivalents. So in other words, if you're a land apply, you know the liming potential of that biosolids. So Class B, now we're talking about land application of Class B or Class AA. Most of the land application is Class B material. Florida DEP is responsible for permitting and the compliance verification of all domestic waste treatment facilities that generate, as well as the sites that are receiving the biosolids. So there's a permitting process. Most of the permittees are not necessarily the landowner. Most of the permittees are rather the haulers, and they also have to go through a very detailed process. So, for instance, if I were to apply biosolids in ONA, in our research center, each site it's considered an application zone. So there's certain requirements, nutrient management plan, a phosphorus index assessment for each individual site. So it's a very complicated and detailed process. And of course, there's also the compliance aspect. So DEP comes and inspects the site to make sure that what you said you were proposing to do, you were actually doing. And of course, the record keeping records on everything that's been done. So currently, there's 140 permitted land application sites in Florida. And here's a picture, whoops, other way, the map of where those sites are located. There's been some changes in where sites in the geographic locations where biosolids being used. Certain counties and certain geographic locations of the state, biosolids application was essentially banned. So we continue to produce material. That means that they have to be diverted or land applied somewhere else in the state. So we see a concentration of more land application sites in the Upper St. John's Water Management District, and that's because a lot of the sites in South Florida are no longer allowed to apply biosolids. I think I mentioned this, I'm referring back to the state regulations, the main difference compared to the federal rules. I mentioned the nutrient management plan. We're going to talk about this phosphorus provisions. As you notice, phosphorus is the main issue here when you're talking about nutrient-related concerns relative to biosolids application. And also the state regulations include some additional management requirements that were not included in the federal regulation, part of 503. Again, unfortunately, I'm not going to have time to go into the details, but again, I want to provide you with a very general overview. So the nutrient management plan is the heart of this. That's what it determines the biosolids application rate, the frequency, what you have to monitor in terms of soil testing, water, tissue testing. As part of this nutrient management plan, there's also this phosphorus assessment, and I'm going to explain to you what that means. The reason that I'm explaining to you what that means is because some of the changes in the proposed changes are related to this, how we calculate this Florida P index. So in order to apply biosolids, we cannot simply say, well, I want to dump. And in the popular press, that word has been used, dump. I don't like that because dump gives the impression that there's no criteria. You are simply disposing material in the field, which is not necessarily what happens in reality. There's also some farmers are not being paid to receive this material. The only benefit they get is the nutrients that they are getting with the material. So there's no economic return other than saving money with fertilizer and maybe liming as well. And this nutrient management plan, I forgot to mention, needs to be signed by this certified nutrient management planner or a PE. So there's a thought process involved in the development of this nutrient management plan. And again, these are all components of the nutrient management plan. I'm not going to go into the details, but you have to know aerials, maps, the soil type, distance from setbacks from any water body, analysis of everything's being added in the field. So that can include manure or other sources of nutrients. How much was applied the year before? You need to take into consideration for the calculation for the current year. So it's a very detailed process. And in some parts, as I mentioned, this last bullet point here, some parts of the state, you have to prove that you have essentially no phosphorus import. That's an additional requirement for certain areas in the state. So the P index, this is where some of the proposed changes are. If they go through, that's possibly where it's going to happen. So the P index is an assessment tool. It's site-specific that predicts the likelihood of phosphorus movement. So what is the difference between P index and just testing my soil for phosphorus concentration? When I test my soil and I have, let's imagine a median P concentration in the soil, 30 parts per million of P. That has very poor correlation with the likelihood of the phosphorus to be susceptible to losses. There are other factors that affect P transport. It's not just the concentration. It's what type of fertilizer material you're adding, and by fertilizer I mean biosolids or inorganic fertilizer. The slope, likelihood of leaching, are there any drainage canals, proximity of water bodies. So this is a more comprehensive tool to predict that P movement. And as I mentioned, it's based on the source of nutrients that you are applying and some of the site characteristics. If you are interested in learning more, there's also been some revisions to this P index. It was originally developed by NRCS, and IFAS developed a very detailed guidance for each county in Florida. So if you are in Hardee County, you go to this IFAS website and you see this detailed information about the soils in Hardee County and how to calculate the P index. But why we are worried about this? This P index, once you go through this exercise, and I'm going to show you in the next slide what that entails, you come up with a number, a rating, and that tells you whether you can apply for the application zone. Again, it's based on the application zone. Tells you whether you can apply biosolid based on the crop nitrogen requirement, or you have to follow the crop phosphorus requirement, which makes a huge difference in terms of how much biosolids you're adding to the site. Of course, plants require much more nitrogen compared to phosphorus, so the application rate is much greater if you're doing the nitrogen-based application. I see food being ready to eat, so that means I need to speed up. P index. So here are some of the proposed changes. The P index consists of two parts, two tables, and this is a self-assessment for each specific zones, each specific application zone. The first one refers to the site transport characteristic. So things to keep in mind, likelihood of soil erosion, runoff potential, leaching potential, and potential to reach a water body. One of the criticisms relative to this table, and so there's different ratings you see in this corner, right-hand corner of this table. For instance, leaching potential. Depending on the soil type, the soil series, you go through this IFAS website, you come up with this number for that particular soil. So the greater the number, the greater the likelihood of phosphorus transport from that site. So in this case, it must be a soil with a very high leaching potential. One of the criticisms from the scientific community is that this exercise, this P index tool, was developed with the primary goal of predicting runoff potential or likelihood of phosphorus being transported by surface runoff, which is not the primary mechanism for phosphorus transport in Florida. Remember, our soils are heavily coarse texture soils with fluctuating water table. So the primary mechanism for phosphorus transport is vertical leaching. And that tool does a relatively poor job, according to some of my colleagues, predicting the leaching potential. So that might be one of the changes in the future regulations, better predicting the leaching potential. Second part of this exercise is related to the source that you are applying. If you had an opportunity to listen to some of my previous presentation, solubility of phosphorus in the source is a very important thing to consider. So, for instance, when you buy phosphorus fertilizer, it's a highly soluble. The intention is to produce a highly soluble material that plants can immediately utilize the nutrients. Biosolids, depending on how they are treated, this phosphorus solubility can vary from anything as soluble as commercial fertilizer to something highly insoluble. So we have to somehow differentiate these materials. So you're gonna see later, I'm skipping ahead a little bit. One of the proposed changes is what are the a priori characteristics in the biosolids that can determine the likelihood or the phosphorus solubility in the material. For instance, materials that are thermally treated, dry pellets. Phosphorus solubility is extremely low compared to, there's another process that's called biological phosphorus removal. Usually biosolids that go through that biological phosphorus removal contains high phosphorus solubility. So we are trying to come up with proposed changes. One of the proposed changes is to develop factors to account for differences in solubility. Application method, most of the biosolids that are land apply are either being applied to pastures or citrus. So usually we're talking about surface application. So you see the number associated. It's the same exercise. One thing I didn't mention is soil fertility index. Basically, is your soil test multiplied by two and multiplied by this factor, you come with this number. That's another source of criticism. As I mentioned, soil test was developed for agronomic purpose. It has nothing to do with environmental risk. So there's better tools to predict environmental risk than using this fertility index value. That's one of the things that are also being proposed. So you come up with this number here, and if it's above 150, you have to either make changes, reduce the application rate, or you have to apply biosolids based on the crop phosphorus requirement. If it's below 50, like the case of this exercise, this example, you can apply biosolids based on the nitrogen requirements of your crop. Let me skip this. So now I want to talk about the tech. So in June last year, 2018, the Florida DEP announced the creation of this biosolids technical advisory committee. And there's links in this slide that contains more information. So they're basically, DEP received a number of nominations. I can't remember the exact number. A lot of people volunteer or they were nominated to participate in this technical advisory committee. And DEP selected 7 members. We have one of the members here present with us today in this room. But if you want to read, and they represent different groups, environmental groups, academia, and also small utilities, haulers. So it was a pretty diverse group of folks that were charged with these 3 questions here. You see in the bottom of the slide. So there were 4 meetings between June 2018 and January this year. And those were public, open to the public. The public had an opportunity to voice their concerns. I had an opportunity to present my research data. But the committee, the TAC committee, the members were charged with these 3 questions. One is, are there any current options for biosolids management in the state? So in addition to land application, are there any other technologies that we can use to manage and dispose this material? The second question is, are there better ways to manage biosolids to improve the protection of our water resources? Basically, in other words, what it's saying, are there any changes in the regulations that need to take place to avoid water quality degradation? And the third question was research gaps. That's where I trying to provide my inputs. What exists in literature? What are the needs? Where are the gaps? And that was another question that the members of the Technical Advisory Committee were asked to provide their inputs. And of course, it was, as I said, there were a number of entities that presented, environmental groups and different entities that also voiced their concerns during these meetings. Also, the link in this website, in this slide, contains all these presentations were recorded. So if you want to listen to some of the speakers, just follow the link and you will see, you'll be able to have access to the information that was presented, including the discussions. And let me tell you, some of the discussions were pretty heated, so quite entertaining at some times. But I mentioned the last meeting happened in January. This committee was disbanded, and now DEP is moving towards the regulatory rulemaking process. So based on this, based on this deliberations of the TAC and the public comments, DEP came up with this list, the summary of the proposed changes. And that's what I want to share with you. Again, that doesn't necessarily mean this is going to be incorporated in the new regulation, but just want to inform you this was what was discussed. So the first thing was the modifications in the permitting process to minimize any risk of nutrient transport. So that basically consists of revisiting the application rates based on site specifics. And I mentioned the soil test might be replaced with the sorption capacity, soil P sorption capacity. So there's also a tool that allows us to predict how much additional phosphorus can a particular soil receive. So it's better than soil fertility test. From the environmental perspective, it gives a better assessment of the likelihood of phosphorus transport. Also, some issues related to water table and hydrology of the site, distance to the water bodies. And I mentioned that some of these parameters might be incorporated in the revised Florida P index. So I mentioned there are some gaps in our current P index. So some of these changes may likely occur in the near future. I mentioned that biosolids right now, from the regulatory purpose, they are treated the same, and they are not the same. And there's not only my data, but there's probably 30 years of scientific data showing that there's large differences in biosolids depending on how they are generated. So DEP is considering incorporating that, and that's the second bullet here, percentage of water extractable P in all biosolids to guide the appropriate application rates. So if my crop requirements, if I'm applying based on the crop requirements, let's say Barriga has 40 pounds of P2O5, but I know that my biosolids has a very low solubility, I can adjust the application rate to account for the difference in solubility. So water extractable P might be one way to account for that. And also establish criteria for low, medium, high risk sites, and that's basically the leaching potential that I mentioned, how we can capture that. There are sites that are the likelihood of transport is much lower. So how can we quantify that in our criteria for land application of biosolids? And there's also some other issues related to frequency of inspection, monitoring, maybe the sites that raise a red flag, whether they are high potential for P transport or they have something that indicates that phosphorus, the likelihood of phosphorus transport is greater. So there might be some water surface or groundwater monitoring associated with those particular sites. And there was also discussion about, which I was happy about, some research opportunities. A lot of the research that's been done in the past was done in under controlled environments, so laboratory and greenhouse studies, which are fine to answer certain questions, but the reality is we need large-scale monitored fields, large-scale fields that we can collect real data to make some of these changes based on science, not necessarily perception, not feelings, but the science should dictate those changes. And also opportunities to promote some innovative technologies for biosolids management. So in one of the previous meetings that I had at the Treasure Coast, there were some invited speakers that talk about different technologies, and most of those were pilot scale. Florida, some of the Florida municipalities have been pretty proactive in terms of creating new technologies. However, some of these technologies that seem very promising in a bench scale, when they are scale up, they've proven to be unsuccessful. So that's another thing that doesn't mean that there's not other technologies, but the reality is the current technology that some that being tested, they all fail. So as I mentioned, the DEP is moving towards this rulemaking process. I'm not sure to what extent they're still willing to take more comments, but I hope that this presentation provide you with at least a little bit of insight to what's going on in terms of biosolids regulation. I promised you that I was not going to share any research data, but just want to quickly mention that some of research efforts. Doing research with biosolids is not something very attractive for a number of reasons. There's lack of funding. It's not probably the most pleasant material to do research with. I have a grad student here that's working with field study with biosolids. She can attest the fact that it's not fun to do, but it's important. We understand that we are part of the problem. If you live in Florida, you are part of the problem. Whether you are ag or urban, you have your contribution towards this problem. best way to dispose this material that we all contributing. So I've been very lucky that the Florida Cannabis Association have been supporting some of my research efforts related to biosolids application and water quality. Some of those publications are going to come up this year, so I'll update probably in the Cannabis annual meeting. I'll be sharing some of this. We also have partnerships with St. John's River Water Management District. We're trying to come up with research protocol to address. Again, we need to use science rather than perception to address this issue. Are there any issues? If there are any issues, how we solve those issues. So I'm just listing a couple. I'll be happy to visit with you about any of these projects, but hope this presentation was informative, and I'll be happy to take any questions here in the room or remotely. I'll start with the room first. And here's my contact information. If you feel free to reach out to me if you have any questions. I'll be more than happy to visit with you. One thing before I move on to questions, I think the educational, this is a picture of one of our field days. We were in the Ying Lu, she's the PhD student right here. She's doing this field work. I think that a very important component is educational. If you Google, you're gonna be bombarded by very biased articles. So I think it's very important. My role as a scientist is not to advocate towards biosolids or rangers or any environmental agents. My role, I see, is generate unbiased science-based information that can better guide these decisions. So just be careful with some of the emotions associated with water quality issues. Sometimes can distract you from the reality. Thank you so much.